Awesome. Whew. Only a couple more talks left. I'm glad the whole audience is here. I know like in a couple hours we're all going to have beer, so hopefully we can enjoy a couple more talks and not fall asleep. So I wanted to do, today I'm going to do a talk about how we build microservices at DigitalOcean. DigitalOcean is a cloud hosting provider, and we like to focus on developer happiness. So it makes sense that all of our internal tools, we want to be happy about how we develop it. And I've seen a lot of talks about like organizationally how people are doing microservices, but I thought it'd be really interesting to dig in and talk about a rather large organization and how we do day-to-day things, like how do we build our code, how do we deploy it, how do we do service discovery, how do we monitor and manage our microservices in production. So just really quick about me, I'm a technical lead on a distributed time series database at DigitalOcean. I have a book called Microservices in Go that's coming out later this year, and I live in Bangkok. And apparently I'm not the person that flew the farthest. I met a couple of people that flew actually farther than me to come here, and I'm sure we all came to just enjoy the wonderful Berlin. Yeah. So I've given this talk before, and some people came up to me afterwards, and they said, man, I love microservices. I have 15 microservices. And I said, well, how many developers you have? And they're just like, oh, we're a startup of like 3 people. So I wanted to preface this that microservices are really an organizational scaling tool. Our engineering team has doubling every year over the last 3 years. And most great companies actually start out as monoliths. So like if you're like a smart startup and you're still like pre-market fit, like this talk is fun and it's kind of cool technology, but don't think that like you need to go change your monolith to a microservice tomorrow. Like I just need to put that warning slide in because otherwise people will come up to me. Cool. So who here is already kind of using microservices in their day-to-day? Oh, wow. Almost half the audience. That's really slick. And just kind of a tally so I can have an idea, like who here uses Ruby in their kind of their backends? Cool, like about 10 people. How about Go? Do we have any Go people? All right, we got like another 10, 12 Go developers. I heard there's some PHP people. Okay, that's cool, that's still cool, you know? If you're making money, it's all right. And how about Java or .NET? Anybody? Okay, wow, okay, so there's still a good bit of that. All right, cool. Just so you know, we started out as a Perl monolith, which couldn't have been worse. We use Ruby for our front ends, but now all of our back-end services are in Go. So my talk is kind of language agnostic, but just so you know, that's what we tend to use. So you might be asking yourself, you're like, okay, you guys have a pretty large infrastructure. You're probably deploying lots and lots of nodes. And I wanted to break it down in that we have 3 different kinds of microservices that we build. We have some microservices which are kind of very consumer-facing. So it's kind of something that you might have, where we might have 12 or 15 nodes deployed of a microservice. And that would be something like our APIs or our websites or kind of customer-facing front ends, right? And then we have some things like that I work on where they get deployed to all of our hypervisors. So I build a metric service. So one of my hypervisors literally gets deployed to about 30 or 40,000 machines. So yeah, I can't mess up those deployments. Now we have some new microservices that actually were given to customers, and the customers run on their virtual machines. So that means we have some services now that are going to be scaling to the millions of customers, millions of virtual machines. And kind of in my talk, I wanted to break down how each of the patterns that we use really scales from some of these smaller projects to our kind of our largest deployments, and the kind of the similarities between each piece of it. So I work on a metrics product. So from the front end, it seems pretty simple, right? You look at a virtual machine, you see your CPU, memory, kind of very standard things, right? But on the back end, there's a lot of different collections because we have to be able to collect metrics from your virtual machine. We may have to collect metrics from your hypervisor. And then we have to store this in a large-scale database and ultimately be able to have this renderable for the user, right? So kind of this talk is this is the application you can kind of think of while I'm talking through different pieces of this talk. So I'm going to break this talk kind of down into 3 or 4 pieces. And the first kind of topic is how we actually build our code. What does it look like as a developer kind of day to day at DigitalOcean? What kind of tools we use and stuff like that. So the first thing, this is always very controversial, is the monorepo. And just for anybody that doesn't know, a monorepo is basically where you check in your entire company's code into a single repository. And it was kind of popularized by Google, and now a lot of other startups are copying. Just as a show of hands, does anybody here use a monorepo? Only 3, 4 people. Cool, cool. So this is funny because this will always be the very most contentious slide, and people will come up to me and they're like, there's no way a monorepo can work. That's just a crazy idea. But when I came to the company, I was like, this is the stupidest thing I've ever heard of. But it's actually turned out really good because what happens is now we have like 15 different teams working on different services. And let's say that you have a cross-cutting concern, like we have a logging team. And the logging team needs to change how the logging gets rendered. So like we render JSON to our syslog, for example. So the logging team was able to, in a single commit, go across 15 different teams' projects and change how the logging worked in all of them. And we could all go in one PR and actually look at it and make a single change across the entire organization. Something that you couldn't normally do is if like every single team had 3 or 4 private repos, you'd be like a 3 or 4 month process of like migrating teams to like a new process, like a new logging system or something like this. So also things like security updates are really nice because, for example, if there's a security vulnerability, our security team can look across all of the projects at once and know every single project that we need to update at one time. So pull request-driven development. I'm hoping that a lot of people do this here. How many people are doing this? All right, 3/4 of the audience. So the 1/4, we're all going to get you afterwards and make sure that you start doing this. For anybody that doesn't know, for the 2 people that don't know, is pull request-driven development says we never check into master anymore. And for us, we don't even keep long-standing branches. So I know a lot of teams, they keep like a staging, a production. We pretty much keep a master, and we make sure that our master is always deployable, and we deploy usually almost every day or every other day to each of our production projects. And every single thing that we do a pull request. And now we even have bots that connect to the pull request and do things like style checking. So we have an entire style guide, so that way there's no nitpicking on pull requests. We have team-specific merge requirements. So like, let's say that I change something of 2 different teams. Somebody from each one of those teams has to approve my pull request if I'm modifying their code. And that way we can always ensure that we get proper code reviews across different teams when we check into the repo. This has been a fun one that's really started coming into our company. Traditionally, we were always doing HTTP JSON REST services. And now we've slowly but surely moved almost all of our microservices over to gRPC. Has anybody here used gRPC yet? Just a couple people? It's cool. So basically, if you're familiar with traditional REST services, one of the biggest problems you run into is keeping schemas. So like, let's say that somebody changes the JSON format of the REST service. It's very difficult to manage that across multiple teams. So what people did, right, is they have like things like Swagger or kind of other description languages to like define what the actual web services look like. And gRPC is really nice because it uses protobufs, so you kind of have a defined format, and it's a compilable format, so that way at compile time, you know that you're going to be able to call this web service correctly. And what's really nice too is then you have instant stubs. So if I'm going to call another team's web service, I can literally just use their proto definitions in my tests, and I can be ensured that I'm actually going to be calling the other team's services correctly. So I definitely recommend, you don't have to use gRPC, but I definitely recommend moving to something that actually has like fixed schemas for your REST services. You're going to get a lot of benefit out of being able to do that, especially if you have, like for us, we have like, I have like 5 or 6 different teams that consume my services. So I can't be constantly trying to work with each one of them to make sure that it works with them. Service discovery. This has kind of been a very fun area. Just out of curiosity, who here uses like etcd for service discovery? Only one, okay. How about Zookeeper? We got, okay, about 5 people. Console? All right, only 5 people? Okay, we'll have to change that. What else? Does anybody else use a different tool for service discovery, just out of curiosity? You can just yell it out if you want. Maybe DNS? Yeah, so service discovery to me is one of the core tenets of microservices. So once you have all these services, if you have some config file that has IP addresses or DNS names of your other services, I think you failed. What I recommend is we use console, and console is kind of great because it's like batteries included. You can scale a console cluster across multiple data centers, and basically it becomes a single dashboard for our entire company. So let's say that I'm trying to find another group's services. I can just come into the console dashboard and I can find where their services are, and I can programmatically be able to use them. So like if they change what servers they run on, my code is independent because my code always just uses console to discover where their services are located. And one of the big things about console is that since it has everything included, it's not like etcd or Zookeeper where you have to build all this infrastructure on top. You can get libraries off the shelf that do everything, and you basically just turn it on. And so this is a traditional front end. So we showed that front end picture earlier. And so we have like 3 microservices. We have a MySQL database. We have our time series database. And nothing ever talks to each other directly. Everything always finds each other through console. So even our MySQL databases are not in our config files. So if one of our network ops teams has to take down a MySQL slave, it's automatically either going to go to the master or it's going to go to one of the other slaves that are available. And if you use something like, for some of our apps, we use Cassandra, it's really nice because if you take a node down, then okay, it doesn't matter. It's just going to use another node. And that way the ops teams can actually grow and shrink your infrastructure out independently of your dev teams. We don't have to get woken up at 3 in the morning because our app needs to get scaled. And then it also very kind of integrates if you're using any kind of auto-scaling techniques. Just as a fun thing, I know this isn't really useful to a lot of people, but when I got to DigitalOcean, whenever we bought new servers, I would have to add the new servers to our list to get metrics. So we would buy like 1,000 machines in Frankfurt, or we'd buy 1,000 machines in London, and I'd have to add them to the list of machines that got metrics. So I was like, well, why don't I just install console agents on all of our hypervisors? And they were like, oh, that's cool, but is console really going to scale to like, 10, 20,000 machines? And we're like, okay, well, let's try it out and find out. So we installed console on like 100 hypervisors in New York, just as an example. And it was like, oh, cool. So then we put it on 1,000. And we're like, cool. And we're like, all right, we're going to take our entire data center in New York and turn console on for the entire data center. And all of a sudden, I get a page from a network ops, and they're like, you know the CPU on our firewalls are pegged at 100% everywhere? I was like, that's not me. So we were like, oh man, this console thing's not going to scale. And it turned out it was really silly, is because console to scale, the machines will gossip between each other. So like you don't need a very good large console infrastructure because every machine will randomly talk to other machines. But it turns out that kills your ARP cache in Linux. So if you raise your ARP cache beyond like 100 machines, which it's defaultly set to, all of a sudden you can scale to like 10,000 nodes on a single console cluster. And we're running them on like 3 virtual machines of like 8 gig of RAM for like 10,000 boxes. So you can imagine it scales very well, and it's great because it's kind of data center aware. And I think most even small startups now are in multiple data centers. This, if you can't use service discovery, you can use DNS, obviously. So deployments. Deployments are always kind of a contentious area, because like every single company I've ever been to does deployments differently, and it's kind of very difficult. I think the one thing that has changed that over the last year is probably Docker. And I would imagine, how many people are actually deploying their production systems with Docker? All right, about 20% of the audience. That's cool. That's a really good jump. And this was like a big contentious for us, because before we had to deploy a lot of things with Chef or Ansible, and now we're slowly but surely moving all of our internal applications onto Kubernetes. And if they can't run on Kubernetes, we still run them in a Docker container, but like on a dedicated machine. And it just makes the deployment so much easier for us. Feature flags. This is kind of one of my favorite things. So I talked about earlier that we only keep master. We don't keep staging and production branches. But sometimes we need to put out code that's like more experimental, right? And the way you do this is we actually have feature flags that are customer driven. So that way we can say, oh, we have this new storage feature and we only want to release it to 5% of our customer base. We can flip the flag for that set of customers, and we even have it in our Slack chat. So like we can actually, while we're talking, we can be like, oh, we can turn on this user for this feature. Or if a feature is unstable, we can actually disable the feature. So this is something that's really powerful, and it's enabled us to not keep multiple branches open or multiple versions of any of our pieces of software. I'm running low on time, so I'm just going to really talk very quickly about how we do monitoring. We're using Prometheus for monitoring. And if you're in a multi-data center setup, I really recommend Prometheus, because you can do things like you can roll up multiple data centers into a single data center, and you can actually get your stats across all of your data centers. And Prometheus is incredibly fast. And it's a pull-based model, so your metric systems never overload if you have lots of metrics, which sometimes we do. They'll just get lower increments of time. And for log aggregations, I know a lot of people like the Kibana Elasticsearch stack. We have a stack we call the Rect stack, which is our syslog, Kibana, and Elasticsearch. And basically, all we do is every single app, no app can write files to the file system, is our rule. We always write to syslog, and we always write JSON to syslog. And what happens is our syslog can actually aggregate. So like our logs, we have several terabytes of log a day. So what happens is we have aggregators per data center. They get aggregated with just straight out of the box our syslog aggregation. And then they get pushed into our New York data center, where they sit in a giant Elasticsearch cluster of like 300 machines or something like this. And this will scale up to pretty much any size. I don't think many people will have much larger logging installations than us. I always like to plug this because how many people here use Grafana? Anybody? Oh, yes, like 20 people. If you're not using Grafana to monitor your metrics, you should just install this tomorrow. If there's just one thing you take from this talk, this is the best tool on the planet. I can't like say that enough. The other thing, the second point you should take away, if you're doing microservices, do structured logging. And for the most part, structured logging means like JSON formatted logs, because what happens is if you use JSON formatted logs, you can actually query your logs. So you can do things like we put the user ID of every single request in our logs. So if a user complains, we can actually strike out and get the logs for a specific user. And what's really awesome, syslog supports this natively now in Linux. So you don't have to install any kind of crazy software to like get this functionality, and then you can use Elasticsearch straight out of the box with that. I'll just skip over this. The last thing I just mentioned is I don't have enough time to talk about is distributed tracing. Basically, distributed tracing is when you have a whole bunch of microservices and they're talking to each other, and you need to find the metrics between each of the microservices. This becomes very difficult, and it's still not very good. If you want to talk to me about it afterwards, I'll talk more, but I think I'm out of time. So yeah, any questions?
Thank you. Can you, while we're on it, touch on how you do distributed tracing? Because that's actually how you track between stacks.
Right. So what we do is we kind of have a poor man's distributed tracing, I would call it. And what we do is all of our internal libraries for Ruby and Go, we pass GUIDs as HTTP headers between the different services. And what we're doing now is we're just logging those identifiers into structured logging, and you'll get them in Kibana. So you can track a transaction in like the actual Kibana unit interface, but you can't get like the nice call stack graphs. And that's something we're starting to look at. Open tracing is a really interesting project, and Lightstep is the back end to actually store distributed tracing.
Go.
Okay. I have a question about communication between microservices, because you said you switched from HTTP JSON to gRPC, but if I understand it correctly, that's still like tightly coupled in a way that if one microservice dies, the requesting microservice would also stop working. And what are your thoughts on doing things fully asynchronous using, for example, PubSub or other ways of subscriptions between microservices?
That's great, and I'm going to answer, I almost hear two questions there. So one is, yeah, so we use gRPC between services, and one of the main tenets we have is services can die at any moment. And usually, for the most part, we have a thing where a service can tell you if it's retryable, is retryable is okay. So what will happen is if a service dies, you just retry the same gRPC request, and you might get routed to a different server the second time. The second question was about asynchronous. And in some cases, we use Kafka. So, for example, we have very high volumes of metrics and logs. For that kind of stuff, we don't use RPC calls. We actually store it into Kafka, and then we consume it like asynchronously. But between microservices that aren't high volume, we don't really use asynchronous services. Yeah.
How do you do server-to-server authentication?
Oh, great. That's a great question, because this was a very painful transition for us. So now we use certificates. And with gRPC, it's really nice because it can actually do certificate pinning, and it can actually validate that the certificate of the other endpoint. And what we did is we set up we have like a special web UI. So if you want to build a new web service, you download certificates for your service. And that's how we authenticate between different services in the company.
Did you have to do some tooling when switching to like a binary format like gRPC for debugging?
Yes. Yeah, so the tooling has been the hardest part, right? So if anybody's used gRPC, it's quite a pain to use the tools. We actually had to build a Docker image to be able to build the gRPCs, because it's always so hard to actually install the gRPC software. As far as the tooling around debugging, you can do interceptors in gRPC, and what we did is we have special interceptors for both metrics and logging that come into our centralized metric and logging stores.
More questions? Great. Thanks again, Matthew. Great talk.